Alright, so for this module, Module 9, we're dealing with supervised learning. So it's machine learning, and we're going to focus on classification. So we've got, I think we're doing 4 or 5 different models that we're going to focus on. I've got notebooks here in the resources page, a variety of notebooks that Vanderplas has provided for us. What I want you to do with this is, we don't have a slide deck for this one. The slide deck is going to be each of these notebooks. I want you to go through each of these notebooks, and they are very straightforward, looking at the different models. So we've got the Gaussian, which is a naive Bayes model, and that's our first one. And we'll just go through step by step, getting that, and we import the model itself, create an instance of the Gaussian naive Bayes model. So that's the constructor. We have now and you can name it something different if you wanted to, but Vanderplas is just saying that's our model. We fit the model with the X and Y data that we've got. We run through and we do it, and it will go through and classify for us. Okay, it's a very straightforward model when it comes to classification. We'll go through and run it as a vectorizer, try and pull features out, and when we come to naive Bayes, we'll do multinomial naive Bayes, different pipeline, and we'll go through and try that. And we go through and we can look at the different values when it comes to the predictions and the true. How'd we end up? How'd it look there? When to use naive Bayes. Now from naive Bayes, we've got linear regression. Go through and try to look at linear regression, come up with a prediction, a line that would tell us, all right, based on what we see already, where would we predict another one would be? So this is one of the most basics, but you're going to do a couple of different ones, and this will help you when it comes to one of the assignments where we've got to use lasso. See here on this one, we go through and we do it. Let me see which one on the sine wave, and see if we've got which one we're using in here. Using linear regression, regularization, which L2. So there we go, ridge and lasso. Things you're going to do in an assignment coming up. I think it's due the next module or the module after. You've got this going on in there. Okay. So take your time going through this notebook, as well as here we got support vector machines. Same kind of thing. You'll see this in the graded notebook as well, step by step. So I said before, cite your source or inspiration for the code. The code exists. Most of what we're dealing with, it already exists somewhere, and it's just a matter of utilizing an existing function to perform a task for us. Here's a function, plot support vector machine decision function. Boom, you pass it the model, and it goes through and it does that for you. It plots it out. Okay. So go through each of these, and I think this is almost the last one. So here you've gone through naive Bayes, you've gone through support vectors. Here we'll deal with random forests as decision trees. And we're going through and trying to classify based on random forest. I think our last one will be PCA, Principal Component Analysis, and the last notebook to play with in this module. So you should go through and explore these, and great resources for the assignments that you're currently working on. Okay. So with that said, I've got links to everything. Let's see here. Here's each of the notebooks. Naive Bayes, linear regression, support vector machines, decision trees, random forest, and PCA. Got some other videos to help you along the way, comparing and letting you understand what naive Bayes is, Bayes theorem. Okay. So with that said, go through these. You've got your discussion and reflection. Discuss the notebooks available that we just briefly ran through. Discuss those in here. The ins and outs, why you would choose certain ones over the other, what you gained from something, maybe some issues, confusion you may have. Discuss it in this discussion. Okay. We'll see you in the next module. Keep an eye on dates when things are due, what you've got coming up to be due in Module 10. Got a lot more to cover in the Deep Learning module, Module 10.